I would like to go over the solutions for the prerequisite check for reading graphs and piecewise defined functions. The first skill in that section is to find the opposite of a polynomial. If you recall, the opposite of a polynomial is found by multiplying the polynomial by -1. So to find the opposite of the polynomial 5x plus 1, we denote it as a negative sign, and then in parentheses we put 5x plus 1. But we understand that the negative represents a -1 that is then distributed to each term. Distributing, we get a negative 5x minus 1. To find the opposite of negative x plus 2, we write that as the opposite of, and in parentheses, negative x plus 2. Then distribute by the -1, which gives us a positive x minus 2. The opposite of negative 3x squared minus 3. We distribute by -1 to get a positive 3x squared plus 3. The opposite of x squared minus 5x plus 1. We distribute by the -1 to get negative x squared plus 5x minus 1. So make sure you understand that when we find the opposite, each sign of the polynomial is changed. So the next two problems are to actually determine if the two polynomials are opposite. So here we're really trying to figure out, are the signs of those two polynomials different? And if each sign of the corresponding terms are opposite, then we do have opposite polynomials. It would be helpful first to write each polynomial in standard form. So in number 5 we have 2x plus 3x squared minus 7. We want to compare that to negative 3x squared minus 2x plus 7. If we write the first polynomial in standard form, that becomes 3x squared plus 2x minus 7. And we're comparing that to negative 3x squared minus 2x plus 7. And we notice that the 3x squareds are opposite signs, the 2x have opposite signs, and the 7 has an opposite sign, and so these two polynomials are opposites. Then we have negative 2x squared plus 5x plus 10, that is in standard form, and then 2x squared plus 10x minus 5x. In standard form, that is 2x squared minus 5x plus 10. So notice the x squared terms are opposite, the x terms are opposite, but the 10, the constant terms, are not opposite, so that makes these polynomials not opposite of one another. Another skill you're going to need is to find f of negative x and simplify. This is when we talk about functions being either even or odd. But we want to look at number 7, f of x is equal to 2x plus 3. So if we find f of negative x, that means to replace the x with negative x and simplify. And so we would just multiply 2 times negative x is a negative 2x plus 3. f of negative x for f of x equals negative 3x squared minus 5x plus 1 becomes negative 3 times negative x squared minus 5 times negative x plus 1. So again, wherever we see the x, we're replacing it with negative x. The order of operations says we have to simplify exponential expressions first. When we square negative x, think of that as a coefficient of negative 1. We square negative 1, we get a positive 1, and then we square x to get x squared. So this is really just a negative 3 times x squared. Negative 5 times negative x is a plus 5x plus 1. And so when we simplify, we have a negative 3x squared plus 5x plus 1. And then f of negative x for the function four times the absolute value of x would be 4 times the absolute value of negative x. But we can think of that as 4 times the absolute value of negative 1 times x. And if we take the absolute value of negative 1, we're just going to get 1. So this is equivalent to 4 times the absolute value of x. Right? A number and its opposite have the same absolute value, so those are equivalent expressions. And then lastly, we have the function f of x equals negative 2x cubed plus 4x. When we find f of negative x, we get negative 2 times negative x cubed plus 4 times negative x. When we cube negative x, think of that as a negative 1 times x. Cubing a negative 1 gives us a negative 1. And then we cube x cubed to get x cubed. So this is really a negative x cubed. 4 times negative x is negative 4x. So simplifying, we have a negative 2 times negative x cubed, which is a positive 2x cubed, minus 4x. So in the section in college algebra, you're going to find f of negative x and then compare it to the original function. Is it the same or opposite? And that's going to tell you about the even or odd properties of it. But again, more explanation to come on that. And then another skill is to graph a function over a specific interval. This helps you understand piecewise defined functions that you're going to get into. And we want to graph, first of all, y equals 4 for x greater than 0. To graph y equals 4 for x is greater than 0, we can make a chart. And the thing we have to think about here is that we're not graphing the function over its full domain. We're going to graph it over a piece of its domain. And the domain has to be values of x which are larger than 0. So we know, for instance, 1, 2, 3, and so on. But the trick is we actually have to figure out what happens at 0, because anything greater than 0 can include 0.001, 0.5, 0.1, 0.000003. In other words, we can get so close to the value of 0 that we really need to figure out what happens there, because we need to graph the point there but just show that it's not really a part of the graph. And so we're going to figure out what happens to the function at each of these x values. Well, the function value is just simply 4, right? Y equals 4. So when x is 0, y would be 4. When x is 1, y is 4. When x is 2, y is 4. And when x is 3, y is 4, right? If you recognize y equals 4, that's a horizontal line, but we're not just drawing the entire horizontal line. We only have it defined for values of x which are greater than 0. So x is greater than 0 is just to the right of the y-axis. Plotting these points, so 0, 4. Now this is a trick. I can't enclose 0, 4 because it's not equal to 0. So I have to put an open circle at that point. And then 1, 4, 2, 4, 3, 4. So everything to the right of 0 is part of the domain of this particular piece, and so that is how we graph this function over the given interval. Now if that had said greater than or equal to 0, then we would actually have a closed-in circle at 0, 4. Now if we want to graph y equals x plus 3 for x less than -1, we'll again make a table. To be less than -1 means my x values have to be -1, again, because it can be so close to -1 that I can't distinguish it from the other value, so I have to include that here, but I'm going to have an open circle because it's strictly less than. So what are values less than -1? Like -2, -3. So if we look at on the x-axis, the values less than -1 are only going to be values to the left, right, of -1. So that's our only values that we can choose for x for this particular piece. If we substitute -1 for x, -1 plus 3 is 2. -2 plus 3 is 1. -3 plus 3 is 0. So we're going to plot -1, 2, but with an open circle because I'm not allowed to equal -1, -2, 1, and then -3, 0. And so whenever I connect the dots, I have to go to the left of -1, and I'll draw my line. Now again, if this had been less than or equal to -1, I would have a closed-in circle at the -1, 2. Let's look at a couple more examples of these. If I want to graph y equals x squared for x less than 0, and let's just make this as x less than or equal to 0 to show the difference between the other two that we've done. So if I make a chart and I want my x values to be less than or equal to 0, right, so that's going to have to be to the left of 0, I can include 0, -1, -2, and then if we square those values, right, y is x squared, squaring 0 we get 0, squaring -1 is 1, squaring -2 is 4. And so if I have x less than or equal to 0, as I've changed that, the 0, 0 is actually a point included in my graph. So I can include that point, 0, 0, then -1, 1, and -2, 4. And you should recognize this as part of a parabola, but the parabola is only defined for values which are less than or equal to 0. And so whenever I draw that graph, I stop at 0, right? I have to only be to the left of 0 for this piece. Now if it was as I originally had, strictly less than, then I would have an open circle on the 0. So you have to keep in mind there are decimal values. We typically think in terms of integer values, but between 0 and -1, there are infinitely many numbers, and so we have to represent that part of the graph. Number 14 is y equals -2x plus 1 for 1 is less than x is less than or equal to 4. So this time we're restricting our values of x between 1 and 4. Okay, so only between 1 and 4. So our graph is going to only be turned on, so to speak, for those values. So when we make a table, I can only choose values between 1 and 4. Now again, I have to choose 1, even though I'm going to have an open circle on it, because there are infinitely many values between 1 and 2. I can choose 2, 3, and 4 is the largest I can be, But my x value is allowed to equal that, so I can actually put a closed circle at the 4. When I replace x with 1 in the function, negative 2 times 1 is negative 2, plus 1 is negative 1. If I replace x with 2, I get negative 4 plus 1 is negative 3. When I replace x with 3, we get negative 6 plus 1 is negative 5. And when x is replaced with 4, we get negative 8 plus 1, which is negative 7. So graphing these 1, negative 1, I have an open circle because I really can't equal the 1. 2, negative 3. 3, negative 5. And then 4, negative 7. It's down here, and I can equal 4, so I will have a closed circle there. And so my graph is just this piece of the line for those specific values of the domain. Now we want to write an interval notation for a piece of a graph. In these examples, I have a graph drawn in black, and then we only want to write the piece that corresponds to the part shown in blue. So the part shown in blue, notice, is to the right of the x value of 2. When we're defining the domain, we want to look at the x value, so we're reading it from left to right. So if I go from left to right on this piece that's shown in blue, I start at negative 2 because it's actually included. We start at positive 2. It's included in the graph, and then that piece extends infinitely to the right, so we end at positive infinity. On the second graph, the piece of blue in blue is on the left, and so when we read from left to right, it is from negative infinity to where does that piece stop? Well, it stops at the y-axis, which has the x value of 0. And so we stop at x equals 0 and have a bracket there since it is included in the graph.